This video is a brief introduction into simple machines. In physics, we call an object that either multiplies a force or changes the direction of a force a machine. Some types of machines are levers, wedges, inclined planes, pulleys, wheel and axle, and a screw. This video will only cover levers, inclined planes, and pulleys. First, let's talk about a lever. A lever looks like this, where there's a flat board or a flat object that is resting on a fulcrum, which can be thought of as a pivot point. When the lever is pressed down on one side, the other side is going to go up, very much like a seesaw. So if the fulcrum is not in the middle, one side will travel further distance than the other. For a machine, the work that is put into the machine is equal to the work put out of the machine. We know that work is equal to force times distance. For lever problems, technically the distance the side of the levers move are like arcs along a piece of a circle. To simplify our calculations, we will just refer to arc length as a particular distance, d. We just discussed that one side of the lever may move more than the other side if the fulcrum is not centered. If this is the case, we know that the force exerted on one side of the lever that didn't move as far will be greater than the side that moved further. This is because we know that the work put into the lever has to equal the work that we get out. Some examples of levers are crowbars, bottle openers, and door handles that are cylinders or rectangles that you press down on to open a door. The next simple machine that we are going to discuss is an inclined plane, which is essentially just a ramp. We know that to push the object up a ramp, we will exert a force over the length of the ramp. The work that was put into the positioning this object is equal to the object's potential energy, or the weight of the object multiplied by the height of the ramp. So it's very important that we see that this weight, or this W here, is weight and not work. So we typically use a ramp when it is difficult to raise an object just straight up. And based off this formula, we can quantitatively see why you would need to exert a smaller force if you had a longer ramp, because the work put into positioning an object would still be the same. If you think about driving a car up a hill, you would much rather, it would be much better for your car to climb a steady hill rather than a steep one, because the steeper hill has a smaller ramp length, and therefore it would require a larger force from your car to get up the hill. A few examples of inclined planes are wheelchair ramps, stairs, and ramps that come off the back of large loading trucks. Finally, the last machine we will discuss is a pulley. The most basic pulley changes the direction of a force that is exerted on an object. We can see from this small image that if I were to pull down on a rope, the box on the other side of the pulley would then go up. So we're changing the direction of the force. Pulleys can also be combined in order to lift multiple objects, like the pulley diagram here. If we draw a free body diagram for each block, we see that they both have their weight forces and they either have one or two tension forces acting up. Since this is the same rope, we know that all these tension forces are going to have the same magnitude. We can also assume that there's no acceleration for these boxes, which means that the forces in the y direction are going to be balanced, or they're going to be equal to each other. So we know that the weight of the 10 kilogram box is 100 newtons, which means that this tension force upwards is also going to have to be 100 newtons since the forces are balanced. And therefore, the tension forces acting up on the 20 kilogram box will also be 100 newtons each. And the downward force on the 20 kilogram box, so the weight force, is 200 newtons. And as we predicted, all of the forces acting on the objects, or the boxes, are balanced, and that's exactly what we predicted, so great. Pulleys are used typically at the top of flagpoles to raise and lower flags, and they're also used on sailboats and during physical therapy or weightlifting machines and exercises.